Morning. It is May 21st. Kind of noisy out here. A lot of traffic right now, and the wife is cutting the grass. Just doing finishing touches on solar water heater. I got my two 10-watt panels hooked up. The water pump doesn't need 20 watts to drive it, but with the two paired together, I just got them in parallel. It starts sooner and runs a little bit longer with less direct sunlight. They only make 10 watts in absolute direct sunlight. So, and I've got them kind of positioned so that the light starts to warm up the panel a little bit before it actually starts pumping water. So as soon as these are making enough power to get the circulation pump moving the water through, it's already hot. And by the time I got a shadow from this big guy, I'll get a little bit of life before the pump stops. So let's go check it out. Alrighty. So this is kind of a complex system here. I did put my T-valves on, so I am hooked up to the winter system and the summer system, and it's just a simple flip of a switch. Turn this guy over and close this guy, and now it circulates through the copper coil in the chimney pipe. And flip her back, and now it's circulating through the thermal collector outside. But the pump is running, and incoming water, well, it's pretty indirect light, so we're not going to get scorching hot today, but the wind turbine is moving, so hopefully the dump load will be activating in a little bit as the batteries fill up. Water temp right now is really nothing impressive. It was cloudy for the last day and a half, so yeah, we're only 84, 85 degrees. Incoming is maybe 97 to 100. It's hard to get a reading with the thermal thing on there. Just, it never seems accurate, but one more time I'll go through the whole thing. So the water going out from the pump, this is going out to the thermal collector, and then this is coming back. It's a two-tank system. It's a two-tank system because I needed an electric water heater so I could put my DC element in there. That is a 24 volt 600 watt DC element. This is wired to my diversion load collector that goes across over there, and that activates at 28.9 volts. It starts to divert power to that, and that'll just help the solar collector. That's not the main source of heat. This is the main source of heat, but it heats both of them from the bottom up. So it comes back, comes in the small tank, heats that from the bottom up, crosses over, comes to the big tank, heats this one from the bottom up, and then goes back up. The winter system does the exact same thing. Goes out, runs through. There's 20 foot of 3/8 inch copper coil inside of there, and then I got that going to braided fittings. If you're going to try to do something like this, you should really know something about plumbing. You know, you got to have thread sealer and get all the correct fittings And I highly recommend, if you're doing a pressurized system, especially with a copper coil and a chimney pipe, don't waste your time or money on anything but braided hose. You're just going to blow hoses. I did it a bunch of times. I tried everything. And it all blew. It all got too hot and just blew, and I had to come down here in the middle of the night and mop up gallons and gallons of hot water. The braided hose, same thing. Comes in to the bottom, loops over into the bottom of that one. Same idea, just 2 different sources of heat. But the chimney pipe collectors, they work fantastic. Absolutely awesome. All winter long our water is like 145 degrees. And some nights, in the dead cold of winter, when I have to burn really a lot of wood to keep the house warm, the water is getting so hot that we have to like purge hot water, do dishes in the middle of the night, or, all right, everybody take a shower. We got, the water's 165 degrees, so everybody take a shower. It all does work really good. It's really complex, and there's a lot of different fail points. So it's important to have all the right fittings, have good gaskets, check everything over, and the first couple times you use it, monitor it. Watch as it's heating up and as it's cooling down, because the different metals all have different expansion and contraction rates as they heat and cool. The rubber, the different gaskets have different contraction rates as they heat and cool. So unless you want a big problem on your hands, you monitor it, you make sure it's going to be okay. And after a week's of testing with the solar thermo heat, and we had a couple cloudy nights, so I switched over and I lit a fire and put new gaskets and everything, made sure it was all sealed up tight, no drops coming out anywhere. So yeah, we're good to go. But see what is close. Problems happen, and if you're gonna do something like this, be prepared to, it's not, you can't just go buy a system like this. You can, I guess, pay some professional thousands and thousands of dollars to throw you a foolproof system together. I guess if I did all copper line with compression fittings and cranked or tight, that would be pretty close to foolproof. But that's expensive and a lot of work, and there's no fuse in the system then. I do still have my overpressure relief valve on this one, but in the wintertime when I'm just running this tank, there is no fuse on the system. So if it does overheat, at least the line is going to blow before the tank. You don't want to, overheat that tank, because they literally turn into a missile, blow the bottom out, and they go that way. And my couch, or no, that's right below the kitchen table. So, you got to have a fail-safe in the system. So, you keep a fuse in the system. So this is a fuse. These gaskets are a fuse. If it gets too hot, if it gets, too high a pressure, your fuse will let go before, something really dangerous happens. But, that's that. It has been a year in the making to get it dialed in right. Just, trial and error, trying different materials, different lines, different coil designs. I started with a 10-foot coil, and I went up to a 15-foot coil, and I went to a 20-foot coil, and at one point it was actually heating too efficiently, and yeah, So, you know, you got to dial it into what you've got, what kind of heat output your fireplace has. And if you're going to do the solar thermo, you got to dial it to how much heat energy you have the potential of harvesting. How much sunlight hours are you gonna get? How direct of sun? You know, do you have obstructions that are going to shade your panel? Because that's going to make a difference. So, you know, that's all. Geez, I hate the term "do it yourself," but because I am not a weekend warrior. This is my life. Our house runs on these systems, and I've just got parts and pieces laying everywhere. Extra charge controllers. I've gone through half a dozen inverters and half a dozen charge controllers and different setups for the wind turbines, different blades. I got blades laying all over the place. And finally, it is dialed. We have no more power shortages. My my poor generator really never gets any use. I fire it up just to run the gas out now and then, but you know, the batteries stay charged. We got basically 1,000 amp hours at 24 volts, so 24 kilowatt hours of total storage. I don't like to discharge them more than 50%, just because they're going to last longer if I don't beat them up. So, and monitoring is important, being able to monitor everything. Right now there's 43 watts coming in from wind. Right now there is 700 watts coming in from solar. Right now the house is using 194. On the AC side, we're only using 170. But we also have a DC side, so this monitors everything, all of the power the house is using. You know, that's my meter for the generator. That's my wintertime diversion load. You have to be able to mitigate over voltage if your solar is making a whole bunch of power and the wind picks up and it spikes. So you got a diversion controller, and that keeps track of voltage. You set it for what your maximum voltage for your batteries is, and if this picks up and starts to kick a bunch of power in, and this, you know, the voltage raises too fast, it spills over. Actually, I'm going to be doing a upgrade on this just for longevity reasons. I'm putting a solid state relay with a big heavy duty heatsink on there, so that'll go in place of this mechanical relay. Not that there's anything wrong with the mechanical relays. They're noisy when they're operating, clicking on and off and on and off and on and off. But they have been known to arc internally and ground out, and that could completely discharge and destroy my batteries, you know, or overheat wires, or, you know, cause a problem where the SSR is not going to do that, as long as your diversion load isn't going to overpower the SSR. You know, I've only got a 600 watt diversion load that's 100 amp relay. It'll never overpower that. So, you know, got to size everything, think about what you're going to use, and how much you're willing to invest. So, anyhow, ended up longer of an update than I had planned, but I haven't shown this stuff off in a while. Just figured I'd show it all. But thanks for watching. God bless you, and take care.